Hello and welcome back. In today's session, we're going to talk about what is API Gateway and what is backends for frontends. We have heard about this term, of API Gateway, but we don't really know why this was introduced in the first instance, right? So let's try and understand what's the need or what was the problem that that was there, which it actually it is trying to solve today. We're also going to talk about backends for frontends. It's nothing but a different kind of implementation in terms of API gateway. So let's try and understand what was the problem statement first. So let's imagine you have an online store that uses microservice architecture pattern, and you have created multiple services as part of multiple microservices, and they are exposed over APIs, and you have developed multiple clients such as web and mobile app in order to get this information and display it to the customer. Along with that, you also have integration with third party apps wherein you would like to publish your information onto different websites or maybe onto the different third party apps. So how do you achieve the connectivity between your clients and your services? So one way of looking at is, let's say you have a web-based application, it has connectivity to your product service, then ratings, and then customer reviews, and also to your order management. Similarly, you have same similar implementation for your mobile. It talks to all these services, and maybe on for your third party app, you don't want your third party apps to talk about order management or your customer reviews. All you want to do is just expose your product and ratings so that that is displayed onto their applications. Now here comes the challenging part, wherein you would like to have this entire system talking to them effectively. By looking at it, we can really see the number of communication channel which are being opened, and we really need to figure out a solution and how do we do this effectively. So let's understand. So how do we establish a better architecture pattern wherein these clients can access these APIs in a consistent way? And we do have certain constraints here, right? So as we see, these are all split into multiple microservices, so every single microservice would do a specific part, and it then there is a need for one of the client to do multiple calls to the backend services or to these APIs, and then get that information, such as, and then it is something we can also call as orchestration, and wherein it needs to talk to multiple microservices and then get that information and then display that information. Also, uh, depending on the client, we would like to pass on restricted information or maybe detailed information for that, for that's client specific information that we would like to pass back. Then we also need to consider the network performance. For an example, if we look at our implementation here, so web is basically wherein we don't expect any latencies because of the network connectivity, which is pretty much steady in we can assume that. But in case of mobile, since it is happening over mobile network, there is a possibility of adding latencies into the application, right? So we need to think about that as well. And also we have another challenge wherein these are all are our microservices, right? And so the number of instances or their locations could be a constraint, wherein if we realize that there is additional traffic, and if we currently have two instances of product, and if we increase that from two to maybe we add two more into it, and now that makes our four instances of product, then how does the client would understand that how many number of instances are there and what are their IPs now, and how do they manage all this communication between these additional instances? So that's a challenge, right? And also we do have a challenge of having diverse set of protocols to achieve certain implementation for, and all of these are not ideally placed for web interaction. So these are our constraints and these are our problem statement, and the solution that we actually have for this is to implement the API gateway. So let's take a look at what API Gateway brings to the table, right? So this is how API Gateway, a standard implementation, looks like, right? So we now have a single point of entry or single point of communication for all our channels, and what they do is they just talk to API Gateway. Now API Gateway is responsible to implement security policies, which ensures that the clients which are retrieving information from the backend are actually authorized to do that, right? So even if we add third party app here, so that would be validated at API Gateway if that a third party application is allowed to get this payment service information, which is something we don't want to expose to them, right? So that is something that API Gateway can solve, along with the challenge of uh, and along with the challenge that we had seen in the earlier page. Now this is the role of API Gateway. So API Gateway now becomes a single point of contact and also can help us do you know client specific operations, such as so this is like mobile application which is calling this, so it can actually implement policies which based on the client identification, it can actually do certain set of processing for that particular client, and the APIs are built in a way wherein they do not perform separate function for separate clients, right? So they do the same function irrespective of the client that's calling them, and this API Gateway then takes the responsibility of doing the required processing for the client specific. It can also help us to do the protocol translation. For an example, it can also help us convert from the REST into the MQ world, right? So it can also help us do that translation. So that is something this API Gateway would help us in terms of simplifying this design, right? So that's the basically necessity why we see API gateways in this microservices architecture. And there is also another way of implementing API gateway, and that is something we call as backend for front end, right? So what it does, instead of having one single point of entry for all the clients, what it does is here we actually put three API gateways, and what we do is we do build them for client specific implementation. For an example, web application will always talk to the web API gateway, and that will eventually talk the the three different microservices, and the mobile, similarly, we can see that we can implement similar implementation for mobile app and also for the third party app, right? So now this actually basically brings in multiple benefits to us, right? So it insulates clients from the implementation of microservices, right? So microservices actually abstracts all the implementation, and all their clients are basically just relying on API gateway to client talk to that microservices. It's also solve the problem of location of instances and the number of instances, because the client doesn't need to worry about the IPs and everything about it, and the API gateway is actually responsible for doing that. Additionally, it actually reduces the number of round trips, right? So and how do we say that, because API gateway is basically the single entry point, and then it actually helps to call multiple APIs, kind of do the orchestration and build the response and send it back to the client. And that's how, instead of the app or the client calling multiple APIs, the gateway does the orchestration part and builds the response and send it back. It actually you know you know also, as I've said, right, so it helps you do the translation from standard the rest based protocol into the different protocols, and it actually hides that implementation from the mobile app. It actually so these are the benefits, right? So but there are certain drawbacks this API gateway brings. Now what that problem is, right? So it actually increases the complexity. So now this since earlier we only had this client and this, this microservices in the place, right? So now we can see we have now this additional piece of components, right, which is coming into the architecture now. We need to take care of, developing and deploying and managing these components as well, along with the additional components that we have, in the backend. It also increases the response time, right? Because as we can see, there is a first hop happening from here to here, and then there is another network hop. So every network hop that we add into the system actually increases the response time, or the latency as we call it. However, if we understand the rewards versus the risk that is happening here, right? So it actually beneficial to have the API gateways in place and then solve the problems that are exposed basically because of the microservices architecture. So that's all for today, and I hope we understand what is the purpose of API gateway, and what's the implementation that we see for backend for front end, right? Which is another implementation of API gateway, a very subtle difference in it, but I think it is beneficial for us to know and understand how this is done, right? Well, thanks for listening, and hope you have find it useful, and see you next time. Thank you.